So the question number 6, find the transfer function of a circuit. The bandwidth of circuit is written as the omega B is equal to omega U by K. The value of K is what? This is the question.
Yes, sir.
Okay. So yeah, I think from the question number 1 you find out. If I go with the so I think my screen is visible to all. Now it is given that, just wait a minute. Hmm, hmm, then question number. Yeah, the circuit for the this is a circuit. Okay, so we use this circuit. First of all, we have to find the biasing. So can you tell me which particular circuit, which particular biasing we are using? Yes, which particularly biasing we are using?
Negative biasing.
Okay. So if I say the terminal of this one is this become minus, this become plus.
Yes, sir.
Okay. Now if I calculate the Vx value or V positive value, so what is the V positive value is in terms of V naught? V naught will be distributed. The current will be flowing in this branch. Okay, so the current is I is V naught upon 50k. Okay, and what is the voltage at this point? V plus. So V plus voltage is I multiplied by the R. I is V naught upon 50k multiplied by the R is 10k. Okay, so that is the V naught by 5, V positive voltage. Okay, now if this voltage is V positive voltage, so this Vx is also V positive. Vx is also V positive.
Yes, sir.
Now, can I apply the KCL at this point? So I can say that 0.2, the current that is coming from this one, it will be going in this direction. So 0.2 minus Vx upon 50k is equal to Vx minus V naught upon 20k. K and K cancel out, so it becomes a 5, it becomes a 2. So it is a 0.4 minus 2 Vx is equal to 5 Vx minus 5 V naught. Okay, so it becomes a 0.4. 2 and 5 is equal to 7 Vx minus 5 V naught. Okay, and what is the value of Vx? Vx value is V positive. So 0.4 is equal to 7 V naught by 5 minus 5 V naught. This implies minus 18 by 5 V naught is equal to 0.4 and V naught is equal to minus 1 by 9 volt. Okay.
Yes, sir.
Uh, this is the V naught. Now what we have to identify in our question is, okay, the bandwidth of the circuit is written as the omega u by k. Okay. So for the bandwidth purpose, what we have, we require the Vx voltage. So what is the Vx voltage is? So from this equation, 7 Vx is equal to 0.4 plus 5 V naught and Vx is equal to 0.4 by 7 plus 5 by 7 V naught. Okay, so we write the equation in the form of Vx form. Okay, now V output. What is the V out? Simply omega u by s. V positive voltage minus V negative voltage, because it is a not a it is a finite bandwidth operation amplifier. So the voltage that we are coming at a positive and negative, that voltage is Vd. Okay, if I say this voltage is Vd, okay, so what is the output? Output is nothing but V naught is equal to omega u by s time Vd. Omega us time Vd. And what is the Vd? Vd is the difference between both terminals. So V naught is equal to omega u by s, V positive minus V negative. V positive minus V negative. Now V positive is V naught by 5. So V out is equal to omega u by s, V naught by 5 minus V negative is what? That is the Vx. Because Vx and V negative both are same. So V negative is what? Minus 5 by 7 V naught minus 0.4 by 0 V naught. 7. Can you solve it? So it becomes a omega naught is omega u by s. If I take of this one, so it is a 35, 7 minus 25 V naught. So it is a minus 18 by 35. Okay, and minus 0.4 by 7. If I take a V naught at the other side, so it becomes a V naught 1 plus omega u by s into 18 by 35. This negative term, when it is come this side, so it is a positive, is equal to minus 0.4 divided by 7 omega u by s. Or can I write a 0.4 as a 2 minus 2 bi by 7
Yes, sir.
omega u by s? So what is the v naught upon vi? That is minus 2 by 7 omega u by s upon 1 plus 18 by 35 omega u by s. Now what we do? Convert denominator as a s by omega u. Convert denominator in a form of s by omega u. So just take a omega u by s and common from the denominator and cancel out with. That is a minus 2 by 7 upon s upon omega u plus 18 by 35. Now if I compare, so it is a naught upon 1 plus s upon omega u form. That means constant is 1. Here constant is 18 by 35. So can I take a 18 by 35 outside? So minus 2 by 7, 18 by 35 outside. So it becomes a 1 plus s upon omega u 37 by 18. Okay. It's become 5. So it become a minus 10 by 19 upon 1 plus s upon omega u into 18 by 37. Okay. And what is the bandwidth? This one. So it is a omega u divided by 37 upon 18. So that is the omega u divided by 2 point. It is 37 divided by 18. 2.05. Okay. Now we compare with the question. In the question it is say that the omega b is omega u by k. If it is a omega u by k, so what is the value of k? K is 2.05.
Thank you, sir. I messed up with the calculations part.
Yeah.
Nothing. Got it, sir. Thank you so much.
Okay. Any doubt in the in this particular solution? So I think now it's clear. So the value of k will be rise from, if you see in the answer, basically portal, it is lies from 1.9 to 2.1.
Yeah, yes, sir. Thank you so much.
Any other doubts? Any other doubts? So shall we go with the weak 8 content? I think weak 8 content is quite easy.
Sir, one doubt. Question number 9 of week 6.
Question number 9 of week 6. Hmm. Week 6. Hmm. Okay. So this particularly will be we have to solve this question. So I think you are aware with the content that professor will be cover. What is the doubt? What is your doubt that I have to solve it, or basically?
Give some hint how to solve this.
Okay. So I think the professor already cover this thing. If we go with the mm, professor's part, wait a minute. If we go Mhm. If I say this is the voltage V1 and this is the voltage V2. Okay. So what is the value of voltage V1? So can I apply the KCL at this point? So the current that is coming from this one is it will be going in this direction. It will be going in this direction. Okay. So can I apply? Yes. Can I apply?
Sir, can you repeat once more?
We are considering the V1 and V2 two voltages. Okay. Now we consider that this particularly voltage is V1 and V2. Can I apply the KCL?
Yes, sir.
Okay. So now apply the KCL point. Which particularly, I think you go with the week 6 content. So it is known as a Sallen key structure. Yes or no? Yes, it is a Sallen key structure.
Yes, sir. Yes, sir.
Okay. Now, if I say that this is the V1 voltage, so what is the value of this V1 voltage is? My particularly current that is passing from this one, it will be go in this direction. Okay. Or can I calculate? This is the V naught. Yeah. So if we are getting the V2 voltage, so V naught voltage is nothing but 0.1 times of V2 voltage. Okay. And if I calculate the impedance of this particularly Hmm, if this is the V2 voltage. So the voltage at this one is V1, and that voltage is nothing but Vi upon SRC. This is the R1, this is the C1, this is the R2 and C2. So SR1 C1. The voltage at this point. Okay, and the voltage at this point is Vi upon S R1 C1 is already multiplied by 1 upon S R2 C2. Okay, so V2 voltage is nothing but Vi upon S square R1 R2 C1 C2. What is the V out? V out is 0.3. So V out is 0.1 times Vi upon S square R1 R2 C1 C2. Now what we have to calculate? Okay, quality factor. So first of all, we can find out the transfer function. So the transfer function is V naught upon Vi, that is 0.1 upon S square R1 R2 C1 C2. Hmm, yes. Or if you go with the particularly lectures, so the Sallen key structure, this V naught upon Vi is something, I think it is a K upon 1 plus S square R1 R2 C1 C2 plus S time of mm, uh, yeah. So if we go with this particularly, yeah, this is the transfer function formula. Okay, so we directly use this formula K upon 1 plus S square R1 R2 C1 C2 S time R1 C1 1 minus K plus C2 R1 plus C2 R2. Okay, We use this formula. Okay. Now what is the omega p? Omega p is what? I compare this one with the second order equation, that is 1 over 1 plus s upon omega p square plus 2s, sorry, not 2s, it is s upon omega p qp. Okay, so first of all we find out the omega p. Omega p is nothing but 1 upon root r1, r2, c1 and c2. This is the omega p. Okay, after the omega p, we know that omega p qp is 1 over r1 c1 1 minus k plus c2 r1 plus c2 r2. This is the omega p qp. So the qp is what? 1 over omega p r1 c1 1 minus k plus r1 c2 plus r2 c2. Okay, now put the value of r1 r2 c1 c2, and what is k? K is 0.1. This 0.1, this is k. This is k, and r1 r2 c1 c2 value is already given. Put this value, calculate first of all omega p, then after that qp. Okay,
Yes, sir.
now how we calculate this formula, you can easily go through with the content. Okay, where the professor solve complete formula. This is a Sallen key structure. Any other doubts? Yes, any other doubts? Okay, so till week 7, the operation amplifier is over. Week 8 is basically related to the subsystem. Related to the system. Okay, and in this system, they basically, the professor will be cover the Bluetooth system or Bluetooth earbuds. I think they are taking the Bluetooth earbud or Bluetooth headphone, Bluetooth headphone or Bluetooth earbuds. Okay, so they are basically consider this one. Now every system is nothing but a combination of multiple subsystems. Okay, so in this particularly, so if we are talking about the Bluetooth system, so there are the multiple subsystems are there. Okay, Mm. The professor discussed that there are 6 different subsystems is available in a Bluetooth system. Okay, now which are what are these particular subsystems is? The main most important subsystem from that one is the power management subsystem. Power management subsystem. That is very useful, very important. Okay, and not only for the Bluetooth system, every system, either we are talking of any particular system, the power management system subsystem is very important. Why? Because it will control, it completely control the working of system. Like for example, if we are saying that my device is not working properly, what is the reason? If the device is not working properly, what is the reason of that one? Either the voltage is not appropriate, or the current is not appropriate. Have you noticed one thing is, sometimes you charge your mobile phone with some other adapter and some other cable, and you can see that your mobile discharge is fast as compared to when you charge your mobile phone with the original. Hello. Have you observed this thing? That sometimes you charge your mobile phone with your original charger, and sometimes you charge your mobile phone with some other chargers. The discharging rate of your mobile phone is faster when you charge with other mobile phone.
Yes, sir.
Hello. Yes, am I audible?
Yes, sir, you are audible.
Okay. So have you noticed that sometimes you charge your mobile phone with your original charger, and sometimes you charge your mobile phone with the other chargers, and the discharging rate of your mobile phone is faster as compared to when you charge your mobile phone with original charger. Have you noticed this thing?
Yes, sir.
Yeah, yes, sir.
The reason of this one? Any idea why this thing will be going on? Yes, why this thing is going on? Why it will be taking the fast discharging as compared to your mobile phone charging? Any idea why this will be happening? No? The basically reason of this one is that your mobile phone shows 100% battery. When you charge your mobile phone with some other adapter or some other cable, but the required voltage and current for this one is not appropriate. Okay, sometimes it shows that your battery voltage is 4.2 volt maximum voltage, so your battery will be the 100%, but the current is not h as particularly the this thing. Okay, so this is the reason that your basically battery will be drainage faster as compared to original charging. Okay, so that's why the power management subsystem is very important. This power management system, what this power management system do, it will be convert your AC 220 volts into the DC signal. Okay, then the DC signal will be convert into the pure DC signal. Okay, okay. Now after that, this pure DC signal maybe we require some different voltage. At one point we require the 9 volt, at one point we require the 5 volt, maybe one point we require the 4 volt also. So basically this pure DC signal will be converted into the different DC voltages, 9 volt, 5 volt, 4 volt, as per the requirement. Okay, as per the requirement. So all this thing will be done by the power management. Again with that one, there is one more thing that this power management unit do is that you have to switch your voltage. Okay, basically switch your voltage so the efficiency is good. So the efficiency is good. You have this particular thing will be also managed by the power management unit. Okay, what is the meaning of efficiency? That sometimes your device is not working. Okay, so if your device that particularly part is not working, so it will be reduce the consumption of that. Similarly, if I am talking about the mobile phone, okay, if I am taking the mobile phone, every time my mobile phone display is not working. So when this particular display is not working, so the power required for the display will be cut down in a way, so we can use that battery for a longer duration. Sometimes the Wi-Fi is not used, sometimes the Bluetooth is not used. Okay, so according to this one, they will basically change the required power with the by different subsystems and manage that thing, so the battery like efficiency will be increased. Okay, so now as we know that for the power management, first thing is we convert the AC signal into a DC signal. How we do that conversion?
Using bridge rectifier.
Yeah, rectifier. Okay, first thing we just require that the high voltage DC 220 volt DC to the lower voltage 20 volts or 12 volts or 9 volt AC signal. Okay, so we required a
Step down
transformer,
transformer.
step down transformer, the step down transformer. The second, this AC voltage will be converted into the DC voltage. Now, for this one, we required a rectifier. Okay, but this particular DC is the pulsating DC. This DC is the pulsating DC. Now, with this DC, with this pulsating DC, we have to convert into the constant DC. So for this one, we required a regulator. Okay. Okay, like for example, if you remember the rectifiers, so there are the two types of rectifier we use. One is the half wave and full wave. Okay, what they do, if my AC signal is like that one, it will be convert the signal either in this form for a full wave or in this form for a half wave. You remember this particular rectifier? You know the rectifiers?
Yes, sir.
Okay. So basically, full wave and half wave rectifier. So on the basis of this one, the AC signal will be converted into the pulsating DC. But the average value of this particularly pulsating DC is somehow this one. Okay, the average value of this one is somehow this one. Okay, it becomes a 1 upon pi, it becomes a 2 upon pi. Okay, average value. If we say this is a VM voltage. Okay, now we have to convert this voltage in a constant DC voltage by using a voltage regulator, by using a capacitor. So we convert this one with the constant voltage. Now, two types of regulators we generally use. One is the linear regulator and one is switching regulator. So we discuss this particularly linear regulator and switching regulator in the next upcoming weeks. So this all work will be done by the power management. This all work will be done by the power management. Clear? Now If you are talking about the second subsystem, so it is a LED subsystem where all the basically LED units, because if you see in the Bluetooth handset there are two types of LEDs are available. One is the red LED and second is the blue LED. Okay, with respect to these LED the power requirement is different. With respect to these LED, we can say the working of these LED is also different. Okay, so second system is the LED subsystem. LED subsystem. Now after that, the next system is the communications subsystem. That subsystem is responsible for all communications. Which type of communication will be done? If you are talking about the Bluetooth, earbuds, Bluetooth headphone, so which type of communication will be done? Any idea? Yes, any idea?
I think communication would be wireless.
The communication is the wireless communication or Bluetooth communication. Wireless communication or Bluetooth communication. Okay. Second, if we are talking about the earbuds, so between two earbuds, there is also a communication. Okay, there is also a communication. Okay, how these two earbud is connected with basically one earbud is connected with the mobile phone and second earbud is connected with the first earbud. Okay, so this is the way. So particularly one earbud will be using as a junction between the mobile phone and second earbud also. So this type of communication is also done with the communication subsystem. Any doubt with the communication subsystem?
No, sir.
Okay. Now the next subsystem is audio subsystem. Okay. All particularly audio related quality like volume high, volume low. Okay. So echo cancellations, anything will be happen. This particularly will be done by the audio subsystem. Okay. So basically, this audio system will be managed, responsible for audio quality and echo cancellation. Okay, audio quality and echo cancellations. Now, next is the sensor subsystem. Okay, can you tell me which type of sensors we are using in the case of earbuds? If you are taking example of earbuds, so which type of
Noise
sensors we are
cancellation.
using? Noise cancellation.
I think there's a touch sensor, like changing the sound and all.
Yeah, one is the touch sensor is there. Okay. Second,
Microphone.
microphone. Okay. Can I say the IR sensors? Okay. Give me. I just give you one example. Is that when basically my earbuds are in the case. Okay. Any which company earbuds I am using, no issue with that. But when my earbuds are in case, it is behave as a off. Okay. In your mobile phone, if you want to connect with the Bluetooth earbuds, it will not connect it. It will be pair, but it will not connect it. But suddenly when I open the case of that particular earbud and just take one earbud out from that case, what will be happen? It will be automatically on. After on, it will be connected with the mobile phone. Okay. And all particularly volume or particularly songs that I play, that will be automatically I can listen from that earbuds. Okay, so it will be detect that when particularly it will be available in the case, when it is not available in the case, it will be automatically on. Again, after it is on, when I put it again in the case, it will be off. It will be off. So this thing will be done with the help of IR sensors. Yes. Yes, any doubt?
No, sir. Perfect, sir.
Okay. So one IR sensor is also connected with your earbuds. That will be managed that your earbud will be inside the case or outside the case. Okay. Sensor subsystem, audio subsystem. Yeah. One is the battery subsystem. Okay. This battery subsystem is used for mm, charging of battery. Okay, charging of the battery. Now, in this particular battery subsystem, charging of battery, and when we are going to charge a battery, the thing is that battery charging percentage, battery charging percentage. Second is if battery is 100% charged, automatically stop charging. Okay, so this will be managed by the this battery subsystem. Okay, charging of the battery. If battery it shows the battery charging percentage, it shows the time period to require. Like for example, if we, in our mobile phone when we connect a charger, it shows that it will be charged in 30 minutes or 40 minutes. Okay, if the battery is 100% charged, it will be automatically stop the charging, so there is no damage in the battery. Like if we are talking about the lipo batteries, if we consider the lipo batteries in our system, the problem with the lipo battery is that like if we are using the two lipo batteries in our system, okay, and we are doesn't create any balancing circuit for that one. Balancing circuit, what is the meaning of balancing circuit? The balancing circuit will ensure that these two battery will charge with the same amount of voltage, like if it is a 50% charge, so that means this battery is again 50% charge. If it is a 70% charge, so the battery of this one is 70%. So it is called the balancing circuit. Okay, if this lipo battery doesn't charge with the balancing circuit, the problem with that is it will be blast. It will be blast. Okay, generally we are not using lipo batteries in our electronic system, but the problem with the, if we are talking about the normal batteries, okay, so the problem is that if the lipo batteries, two batteries or more than two batteries are there, and if the batteries are not charged equally, may be possible that there is possibilities of blasting. So this all managed with the balancing circuit for battery will be managed by the battery subsystem. Okay, so mainly these particularly subsystems, if we are talking about any of the any electronics product, so these particular subsystems are the important subsystem. Along with that, some additional subsystems are also there, like for example, hmm, hmm, yeah. So there are maybe possible that there are several other subsystems are, like for example, according to application, according to the requirement, the subsystem may be higher or lower than that one. But if we are talking about the Bluetooth headphone, Bluetooth earbuds, these are the 6 primary subsystems that we use. Okay, so in this from week 8, 9, 10, 11, we go with this subsystem mainly. As I already told, the main important subsystem is the PMU, Power Management Unit. Okay, any other doubts?
Yeah, sir. I have a question.
Yeah,
Like, sir, in this Bluetooth system, there
your
are two
voice
kinds.
is not clear. Your voice is not clear.
Hello.
There are too much. Yeah, there are too much noises from your background.
Okay, I think now is it clear?
Yeah, yeah, yeah,
My question is like in this Bluetooth system, like there's a lots of subsystems. So for the
yeah,
managing these subsystems, is there any MCU unit like when
yeah.
the red LED will be on and off? So for example, if we are charging, so there is a unit which basically tells us like how many time it would we take. So there's a
Mhm.
lots of calculation behind it. So for that calculations and all, is there MCU unit as well,
Yeah, yeah,
microcontroller?
exactly. Exactly. To
Uh,
manage
sir,
all the subsystem, to manage all the subsystem without this particularly any controlling unit, it is not possible, no? If we are talking about the subsystems, different subsystems, to manage this subsystem working, to manage the basically interconnect these subsystems, we required a MCU unit. Okay.
yes,
Like if I draw the circuit diagram of basically block diagram, not circuit diagram, block diagram of this one. So one is the controlling unit. Okay, and with this controlling unit, we connect as a power management unit, then battery subsystem unit, then LED subsystem unit, with this audio subsystem unit, with this sensor subsystem unit. and one more is the communication subsystem unit. Communication, or we can say the connectivity. Communication subsystem unit. Okay, and this particularly will be controlled by the MCU controlling unit, or the MCU or MPU microprocessing. Okay, mainly we use the microcontrollers. Mainly we use the microcontrollers. Okay, but that particularly simple component that is only used for the managing all other subsystems by connectivity, by particularly uh, calculation part. Okay, but that is not a subsystem. That is not a subsystem, because only the work of that particular subsystem is to connectivity, different subsystem. Okay, yeah, now clear doubts.
Yes, sir. Got it.
Okay, now this power management unit is also connected with some other subsystems. It is connected with the battery management, it is connected with the LED, it is also connected with the audio, it is connected with the sensors unit and communication unit. With all other subsystems, it is the connected with the power management unit. Okay, battery unit is also connected with the LED unit, because in your mobile, in your basically Bluetooth headphone, you can see that sometimes your battery is full. Okay, sometimes your battery is full, your LED will be blue, and automatically the battery will be in drainage mode, like for example it is around 10%. Okay, it is around 10%, so automatically the light color will be changed from blue to the red. Okay, so the battery subsystem is also connected with the LED. Okay, uh, these all unit are basically, we can say it is interrelated to each other. Okay, now yes, one more thing is that don't be confused that with the power management unit and the battery or charging subsystem. Don't be confused with the power management unit or battery or charging subsystem. Battery or charging subsystem. Okay, don't, these two are not a equal. These are relatable but not equal. These are not same. Okay, the battery is basically, if you are talking about the battery, this battery charging system will be only responsible for the charging of battery. Okay, charging of the battery. The health of battery. Where power management unit will be responsible for the optimum utilization of battery. Optimum utilization of battery. That means how we can manage, how we can control the things. So the subsystem that is not in use, so according to this one, your battery performance will be increased, your battery utilization will be increased. So this particularly will be done by the power management. Okay, so these two are completely different. Yes, anyone want to ask?
Yes, sir. I basically sent a message in chat. Basically, I'm traveling, so my voice isn't clear.
Okay, no problem, no problem with that. You understand? You are asking the question now, so you understand? Your doubt is clear? Son, one more, like we can overcome this microcontroller. Can we design a specific chip as we learning in the digital system design? So, like in large scale, which is used either they go with microcontrollers or design a specific IC for this one. Actually, okay, yeah, we can design a specific chip for that one. But the problem with that is if we design, like for example, if I am a I I just a owner of any company, okay, and I design one optimum chip that is used for this, that will be manage this all this thing. Okay, I am not using a microcontroller. The problem with that is that this particularly optimum chip will be used by me only. Okay, I cannot scale that one. I cannot scale that one. If like for example in the future, if I want to change some parameter, if I want to add some other features, okay, so it is a problematic. Why? Because we already specify a chip that is used with some specific, okay, and if I want to change the task, it is a problematic for me. So in place of that one, the it is recommended that you can use a microcontroller. So if in a future part, if you want to change anything, you can change easily. Okay, the thing is that, like for example, initially nowadays I design one earbud, okay, and I want to give the that lifetime of that ear, basically timing of life cycle of, or basically time period is 30 hours. Okay, now according to the, as per the customer requirement, the customer want that my earbuds will be working for 50 hours. Okay, and for the 50 hours working, I have to do some changes. The changes is that I can reduce the LED part, basically power of the LED. I can use some small LED, so the power requirement for LED is less. One change I can do. Second change what I can do is, uh, in my first system, if my earbud is idle for 30 minutes, it will be automatically behave as a off. In the second case, what should I do? If my earbud is not working for more than for 10 minutes or 15 minutes, automatically my earbuds will be behave as a off. Okay. Third thing I can change is that I can increase the power or basically voltage or the rating of the battery. Okay, so these three changes I can done, and according to that changes my battery time period is increases from 30 hours to 50 hours. Is it clear? Any doubt, Utkarsh?
No, sir. Thank you.
Okay, now if I design a specific chip, okay, that will provide the current to LED is constant is at 20 milliampere or microampere, but I use a LED that is required a less current. Okay, so what should I do? I have to design a system again. I have to design a chip again. So that's why we can design, if or if I am not considering that I am not creating some other product, I don't want to upgrade that one. Okay, and my requirement of the users is very huge for this product, So in that scenario, we go with a specific chip. Okay. Any other doubts? Any other doubts? Yes. No doubts? Uh, Along with that, they explain individual subsystem one by one, like in the communication and connectivity subsystem, what they are used, they are require the mm, so that's we take. If we are taking the mm, if we are taking a connectivity subsystem, I think connectivity subsystem. In this, we required a antenna that will be used with the connectivity between the mobile phone and the. Now, with the respect of this one, we are receive the RF signal. Now, with the RF, we required a baseband system. Then, I think we required a link, and that is the connectivity layers. That is the connectivity layers. Here we are using this connectivity subsystem. Okay, along with that, we required a power amplifier, LNA, low noise amplifier. Okay, but these are the main connectivity subsystem. Now, if you are talking about the audio subsystem, so in the audio system, we are required the DSP unit, signal processing unit. Okay, we require the interpolation. We require the digital to analog converter. Okay, if we have a in the audio, we have a particularly two ear. Okay, two earphones. So we can say the earphone or headphone left, or the similar. We require a DAC, the interpolation. We require a earphone, right? And then DSP. Okay, in the DSP, if we say it, we have a equalizer, noise reduction. Okay, then filtering. Generally, filtering is not required. Yeah, so we require the less filtering. Less filtering part is required, but equalizer and noise cancellation is very important. Noise removal is very important. Okay, because the signal that will be transmitted from the mobile phone to your earbud through a Bluetooth or through a wireless channel, there are lots of noise are introduced in that. Okay, lots of noise are introduced in that. To overcome this noise, to equalize the signal response, we use the equalizer and noise reduction. Okay, similarly, in the audio system, we are a microphone also. So in the case of microphone, the system is completely different. It is a reverse process. In this particularly part, it will be going to the up or down from DSP to we go to the interpolation. From the interpolation, we go to the DAC. From the DAC to earphone, right? DSP to interpolation, interpolation to DAC, DAC to the earphone. Now, if we are talking about the microphone. So in the case of microphone, the signal will be coming from the microphone. Now we require the ADC. Then in case of interpolation, we require the decimation. Okay, interpolation and decimation, I think you are aware in the signal system part. Okay, and that particularly through the decimated signal it will be go to the DSP unit, signal processing unit. Okay, only one microphone. If we have a two microphone, like if you are talking about the earbuds, every earbuds has a individual earphone and ear, basically microphone. So microphone right. Similarly, if you are using the microphone left, again we have the ADC, then decimation, and then again a DSP. Okay, DSP unit. So the thing is that we required a single DSP unit. So in place of multiple DSP unit, we require a single DSP. Okay, that is enabled with the equalization and noise reduction. Okay, so this is the audio subsystem. Okay, now the charging subsystem. Okay, for the charging, mm, I think you are aware with the charging profile of your mobile phone. Every mobile phone has a fast charging. Okay, fast charging. So what is the profile of that one is that in the initially from 0 to 10% it is a slow charge. Then from 10 to 90 or 80% it is a fast charge. Fast charge. Okay. Then after 90% it will be again go to the slow charge. So the 90 to 100% again a slow charge. Okay. This is the general profile that we are saying when we are going with the fast charging. So 10 to 90% it will be a fast charging, except this one is the slow charging and slow charging. Okay. Now where 90 to 100% mainly is this region, the voltage is increasing. Voltage is increasing. 0 to 10%, sorry, 10 to 90% mainly the current is increasing. Okay. And 0 to 10% voltage and current both are increasing. Okay, voltage and current both are increases. This is the profile generally in the mobile phones we are seeing. Like for an example, if I have a battery of 5000 mAh, okay, so, and with the 4.2 volts, okay, so it is just shows the 100% battery. Now, what is the meaning of 0% battery? Is that the current is 0 mAh with the voltage is around 3.2 volt or 3.4 volt or 3.5 volt. The voltage is not completely zero. Only the value of current should be reducing. Now, in the 0 to 10%, that means 0 to 500 mAh. Okay. Your current is increased as well as voltage is increased 3.2 to, if I say that 3.2 volts, so 3.2 to 3.4 volt. Okay, the current will be increased from 3.2 volts, so voltage will be increased from 3 0.2 to 3.4. Clear? Now 10% to 90%. That means 500 to 4500 mAh. The current is increased as well as, but your voltage is constant, almost 3.4 to 3.5. A less voltage will be increased in this range. Okay, and after 90%, your current is increased 500 mAh, 4500 to 5000. Okay, or I can say the 5000. So the current will be increased up to the 500 mAh, but voltage will be increased from 3.5 to 4.2. Okay, so your charging profile will be divided in three parts. Charging profile will be divided in the three parts. So in the three parts, we require one part is the constant current. Constant current source. Okay, in the second part, we provide a constant voltage source. So the constant current will be provided by the constant current source unit, and constant voltage will be provided by the constant voltage source. And with this, with the help of this one, we are taking one battery positive terminal and one battery negative. Okay. Just any doubt? So these are the three mainly three subsystems. The next subsystem is the power, LED, and sensor subsystem. We will discuss in the next class. Okay. So,
Okay, sir.
Okay, sir.
yeah. Hello.
Yeah, thank you, sir. It was an amazing
Yeah.
class.
So thank you.
Excuse me, sir.
Thank you, sir.
Yeah.
Sir, when we will get the G form for the lab components?
Uh, I already informed the support team 2 or 3 times, so maybe they are saying that today they will share it with you. Okay, it is not from my side, it is from the operational team or support team. Okay, so they will ensure me that they will share the G form today, but I am not sure that they will share it with you or not today.
So, sir, I should wait for the G form or should I buy it myself?
If you find a option, so better that you can buy it from here.
Okay, sir.
Okay, if you are facing any issue in the buying, then you directly uh, I think you send a mail to the support team that we are unable to find these components, so kindly provides support for that. Okay, so maybe when you are sending a mail to the support team, after that they will share the G form.
Okay, sir.
Okay, otherwise better if you find from somewhere else, you can purchase that component.
Okay, sir.
And may probably on Thursday we will